right, for these socratives, we're going to look at applying Newton's first law, second law, third law, and our understanding of weight in these first 9. So one of the big keys is you have to know which situation you're going to be applying to that question to help you answer it. So first and second laws, they deal with the forces on an object. So if you have a single object, you're talking about the forces on that object. Think about that keyword on. Then we're either looking at, is it a first law problem? Those forces are balanced, the acceleration's 0, the velocity's constant, net force is 0. All of those things are true. If I can just identify one of them, the rest are all true. If I can identify one of these, meaning the velocity is changing, well then all of these other things are true. Or if there is a net force, well then the velocity is changing, there's an acceleration, unbalanced forces. So if I can identify it as one of those, when I'm talking about forces on it, I can kind of know the rest of the ones in that category. If I'm talking about the forces between objects, then I'm using Newton's third law, which just says those forces between objects are opposite and equal. And then we are doing one, I believe, in here where we talk about weight. All right, so let's get started.
Number 1 says, when you're driving on the freeway, it's necessary to keep your foot on the accelerator to keep the car moving at a constant speed. In this situation,
all right, key word there, constant. Constant speed means first law. So what does that tell me about the net force? 0.
So yeah, the correct answer is the net force on the car is 0. Let's take out the next one. A worker pulls horizontally on a crate on a rough horizontal floor such that it moves forward with a constant velocity. In the picture below, force A is the pull of the worker and force B is the force of friction due to the floor. Which one of the following statements about these forces is correct?
You saw constant velocity, didn't you? I heard it, constant velocity. Constant velocity, what's that tell me about the forces? They have to be balanced.
Yep, C. Next one. Assuming you like chocolate cake, which would you rather have?
Chocolate cake. So you want the most amount of matter of chocolate cake. So they all have 1 Newton, so you want the one with the largest mass. Well, on which g value, which acceleration of gravity, are you going to have more mass to produce the same amount of weight? The g value that is the smallest. So go eat your chocolate cake on the moon.
Yep, B. All right, next one. 3 books are at rest on a table. As shown, the net force on the middle book is...
Which of Newton's laws am I going to apply to these books?
Yep. D. A rocket firing its engine and accelerating in outer space, no gravity, no air resistance, suddenly runs out of fuel. Which of the following best describes the motion after burnout?
Little trickier here with the rocket. So as soon as it loses its thrust force, there's no air resistance, no gravity, essentially what forces are left on it? None. So if there are no forces left on it, velocity is constant.
Yep, C. 6. A person pushes with a constant horizontal force F on a box of 250 newtons. A 250 Newton box resting on a frictionless horizontal floor. Which of the following statements about the box is correct?
Frictionless floor. So as soon as I start pushing on, is there anything to resist its change in motion that I'm trying to make happen with my force? No, so there are unbalanced forces. There is a net force. That means that object is going to undergo a change in velocity. It's going to have an acceleration. If there's only one force, there's got to be acceleration.
A. A golfer tees off and hits the ball with a mighty swing. During this brief time, the golf club is in contact with the ball.
But it's a mighty swing. How could they possibly be equal and opposite?
A. A worker pushes horizontally on a 2,000 Newton refrigerator on a kitchen floor with a force of 25 newtons.
So we have a fridge, we have a person, we have 2 objects, and we're talking about the force between them. So the person pushes with 25, the fridge has got to push back with 25. Newton's third law.
B is the correct answer. You slide an 800 Newton table across the kitchen floor by pushing with a horizontal force of 100 newtons. If the table moves at a constant speed, the frictional force with the floor must be...
Oh, I heard it. Constant speed. Constant speed. What's that tell me about those forces? They got to be balanced. So if you're pushing with 100, friction's got to be countering with 100. So those forces are balanced.
B.